Earth, our home planet, a tiny blue dot floating in an immense cosmic ocean. Here resides everyone you have ever known, every human who ever lived, every joy, every tragedy, every war, every love story ever told, all of history, all of culture, every whispered thought and shouted dream. Everything that has ever mattered to us began here, on this fragile sphere suspended in darkness. This is where our journey begins. But to understand our place in the universe, we must leave home. As we slowly pull away from Earth, the familiar fades. Continents blur, oceans merge into a single, deep blue. The thin veil of atmosphere that protects all life becomes visible for what it truly is, a delicate membrane separating existence from oblivion. We pass beyond the atmosphere, beyond the reach of breathable air, beyond the comforting pull of gravity that has held us since birth. Our first destination is the moon. The moon orbits Earth at an average distance of about 384,000 kilometers. That number sounds manageable until you try to imagine crossing it. If you were to drive a car at a constant speed of 100 kilometers per hour without stopping, day and night, it would take more than 160 days to reach it. From this lunar vantage point, Earth appears small, a luminous marble of blues and greens floating silently against a backdrop of endless black. Borders vanish, conflicts disappear. From here, Earth does not look divided. It looks precious, vulnerable, alone. This is Earth as seen from the moon. And already, perspective begins to shift. We continue outward. The next major milestone on our journey is the Sun, lying approximately 1 astronomical unit away from Earth. 1 astronomical unit is about 150 million kilometers, a distance so vast it is used as a standard ruler for measuring the solar system. Light traveling at nearly 300,000 kilometers per second takes about 8 minutes and 20 seconds to make the journey from the Sun to Earth. Every ray of sunlight you have ever felt began that journey long before it touched your skin. If you attempted the same trip in a commercial jet flying at around 900 kilometers per hour, it would take you nearly 19 years to arrive. This distance is not empty. It is filled with invisible forces: solar wind, magnetic fields, radiation. The Sun, a colossal nuclear furnace, pours energy outward across this vast gulf, sustaining life on a tiny planet that orbits far beyond its blazing surface. And yet, in cosmic terms, this is still close. We push farther. Beyond Earth's orbit lies Mars, our enigmatic red neighbor. At its closest approach, Mars comes within about 54.6 million kilometers of Earth. At its farthest, when the two planets are on opposite sides of the Sun, that distance stretches to more than 400 million kilometers. Even at the closest possible alignment, traveling to Mars at the speed of a commercial jet would take over 50 years. This vast and shifting distance is why space exploration is so difficult. Every probe, every rover, every mission to Mars must account for constantly changing orbital dynamics. Space is not static. Everything moves, and still, Mars remains one of the closest destinations beyond Earth. We leave the inner solar system behind. As we journey outward, the planets grow fewer and farther between. Jupiter looms like a giant sentinel, its gravity dominating the solar system. Saturn follows, encircled by rings. Uranus drifts in cold silence. And then we reach Neptune. Neptune lies roughly 4.5 billion kilometers from Earth. Sunlight takes more than 4 hours to reach it. Even here, the Sun is still present, but diminished, a bright star rather than a blazing disk. Neptune marks the edge of our familiar neighborhood. Beyond this point, the solar system begins to fade into something less defined, less understood. In 1977, humanity launched a small spacecraft named Voyager 1. It was built with late 20th century technology, primitive by modern standards. And yet, it carried with it an ambition that far exceeded its size. Voyager 1 has now traveled for more than 4 decades. It has crossed over 22 billion kilometers of space. It is the farthest human-made object from Earth, a silent wanderer drifting through the cosmic sea. In 1990, at the suggestion of a renowned astronomer, Voyager 1 turned its camera back toward Earth for one final image. From a distance of about 6 billion kilometers, our planet appeared as a single faint pixel suspended in a sunbeam. That image became known as the pale blue dot. From that perspective, every human conflict, every empire, every ideology, every triumph and failure collapses into insignificance. Our entire world reduced to a speck. Beyond Neptune, beyond the planets, lies the Kuiper Belt, a vast region of icy debris. And beyond that, the Oort cloud. The Oort cloud is a theoretical spherical shell of icy objects surrounding the solar system. It may extend up to 100,000 astronomical units from the Sun, nearly 2 light-years. At these distances, the Sun's gravitational influence weakens. Objects drift slowly. Time stretches. Eventually, we reach the heliopause, the boundary where the solar wind is stopped by the interstellar medium. This is the edge of the Sun's domain. Beyond this point, interstellar space begins. Here, our star no longer rules. We leave the solar system entirely. Our next destination is the nearest star system, Alpha Centauri. Located approximately 4.4 light-years away, it is the closest stellar neighbor to our Sun. A light-year is the distance light travels in 1 year, nearly 9.46 trillion kilometers. At such distances, astronomical units become meaningless. If Voyager 1 were headed toward Alpha Centauri, traveling at about 17 kilometers per second, it would take over 70,000 years to arrive. This is the reality of interstellar space. The stars are not close together. They are islands separated by unimaginable gulfs. And yet, Alpha Centauri is considered nearby. We zoom out further. Our home galaxy, the Milky Way, spans roughly 100,000 light-years in diameter. It contains hundreds of billions of stars, each potentially hosting its own planetary systems. Somewhere within one of its spiral arms, a small yellow star hosts a tiny blue planet that developed life capable of asking questions about the universe. Within this galaxy exists a small region known as the human radio bubble. It extends roughly 100 light-years in all directions from Earth. This bubble marks the farthest reach of our radio and television signals. Beyond this boundary, the universe is unaware of us. Any civilization farther away than this bubble would have no evidence that humanity exists. Our entire technological history would be silent. Compared to the size of the Milky Way, this bubble is microscopic. We leave the galaxy. Between galaxies lies intergalactic space, vast, dark, and mostly empty. Galaxies drift like islands in a cosmic ocean, separated by millions of light-years. The Milky Way belongs to a small group of galaxies called the local group, which includes over 50 galaxies spread across about 10 million light-years. Light takes 10 million years to cross this region. Even here, our galaxy is not special. Beyond the local group lies the Virgo supercluster, a colossal structure spanning over 100 million light-years. It contains thousands of galaxies bound together by gravity. And beyond that, an even greater structure emerges, the Laniakea supercluster. This immense region of space spans more than 500 million light years and contains the mass of 100 million billion suns. It is a vast cosmic web of galaxies flowing toward a gravitational center known as the Great Attractor. Our galaxy, our local group, our entire known cosmic neighborhood is just one tiny thread in this enormous structure. We are not at the center. We never were. Finally, we reach the limits of what we can see. The observable universe stretches about 93 billion light years in diameter. This seems impossible, given that the universe is only 13.8 billion years old. The reason is expansion. Space itself is expanding. Regions of space are moving away from us faster than light, not because objects are traveling through space faster than light, but because space itself is stretching. Beyond the observable universe lie regions we will never see, galaxies forever hidden, entire cosmic histories beyond our reach, and perhaps beyond that, even more. The true size of the universe may be infinite. And so, after traveling from Earth to the edge of everything we can observe, we are left with a humbling realization. Our planet is small, our history is brief, our influence barely extends beyond our cosmic doorstep. And yet, from this tiny blue dot, we have learned to measure the universe, to map it, to question it. We may be insignificant in scale, but we are not insignificant in curiosity, and that may be enough.